Hey everyone, so this video is going to cover the grep command. If you prefer text format, feel free to check out my blog at villaroot.com, and we'll pretty much be following the same format as that, along with this cheat sheet that I provided. On the left are the options that you can use with grep, and I'll be going over. Then on the right side are the regex characters that you can use, and I'll also be covering that in the videos. So to start off, we'll just do a basic command. The syntax of grep is as follows, where it's the command grep, the options that you want to provide if any, the pattern that you want to search for, and the file. We'll also go over piping to grep, whereas it gets the output of previous commands, and you perform a grep search on that. A simple grep command would be as follows, where I want to search for the pattern user, and I want to look in this file called example.txt. Pressing enter performs the command, and if there's matches, it will be printed out below, and if there's no output, then that'll mean there is no matches based on the options and the pattern that you provided. So first we'll get into printing lines before, printing lines after, and then printing lines before and after. To print a line or lines before, you use the dash uppercase B. To print lines after, you use dash uppercase I, and to print lines before and after, you use dash capital C, and then you follow it with the number of lines that you want to output. So to print one line before, we'll use this B1, and we can see that it prints the line right before the match. To print the line after, dash A1 to print one line, and we can see the line right after the match. Now to print a line before and after, save some key spaces rather than doing dash A and then dash B, you can use the dash uppercase C. If you want to print more than one lines, of course just increase the number from 1 to however many numbers that you want to print. So to give an example of more of a sysadmin use case with this, I move over to my var log folder, and in there's a file called messages, which has a variety of messages relating to mail, authorization, crons, and so forth. So if I want to see any failures that occurred, then I can do something like this, where it's grep fail messages, and it'll present matches with fail in it. So maybe I want to see what's occurring before and after these failures, which is where I'll use these dash A, B, or C. In this case I'll use dash C, and I usually provide it with a number such as like 5 or 10 to get a better idea of what's going on. So running the command, it groups it into sections. It has these dashes that separate between the matches, and you can see the match of fail right here, and then it prints 5 lines before and then 5 lines afterwards. So this is a pretty common situation that I would go through whenever I was a sysadmin. I would search for the text either fail, error, or exception, and then I would get the lines before and after to see what might have caused that failure or error. So now let's cover searching case insensitive, which is dash lowercase I, and then searching recursively, which is dash R. So first dash I, the syntax will look as follows, where you just provide grep dash I, the pattern, and then the file, and it'll perform a case insensitive search. So if we try looking for that same pattern as before of user in that same file of example.txt, but this time searching case insensitive, you can see it grabs an additional pattern of user, but this case with an uppercase U. And if we go back to the var log directory, this time let's look for the text error in messages. We get one result. So now let's look for error again, but this time case insensitive. And we can see there are many more results with error with the capital E. It also grabs the results of error with the lowercase e because it doesn't care what's uppercase and what's lowercase. Say you don't know the file that has the pattern that you want to look for, or you just want to search through the directory that you're currently in, and you could play around with this asterisk. So you could provide the asterisk followed by text, and it would search for files that have that text at the end. And you could do the opposite, where you could do text before the asterisk, and it'll search for file names with that text at the beginning. And then you could do asterisk surrounding text. In this case, asterisk WordPress asterisk will search for any files that just has the word WordPress inside the file name, whether it's beginning, middle, or end. So let's try out that first example. This time we'll look for the pattern password, followed by the asterisk to look in all the files in the current directory. And on the left, it'll show you the file that it was found in, which in this case was two different files, example.txt and then a file called WordPress creds. Now let's look for the pattern user, and this time let's look in all the .log files. And as you can see on the left again, it prints the file names that it was found in, which was 4 different names, and it all ends in .log. You could do this with .txt, .py, or it doesn't even have to be an extension, just any text you want to trail after the asterisk. Now let's do a use case where we're searching for user in any file that begins with the word may, and we get multiple results in several different files, but they all start with the text may. Now let's try where we surround text with asterisks to search in any file that just contains the word WordPress in the file name. We get multiple results again, and you can see in the file names we have the text WordPress in different locations. So the first two, WordPress is in the middle, and then we see WordPress at the end of the file name, and then lastly WordPress at the beginning of the file name. Now to go through searching recursively, which is a very common use case, you use the -r, and basically what that'll do is it'll search through the directory you're in. Any directories that's in that current one, it'll go through there, and then search in that directory. Then it'll see any directories in that one, search through there, and so forth until it goes through all the directories. So I went back a couple of folders, and I listed where I'm currently at. So we'll try searching again for password. We'll provide the asterisk because we don't care which file it is. We want to search through all the file names. And then we'll give it the option of -r to go through all of these directories and search inside there. If there's any directories inside these, it'll also search through those and so forth. And on the left again, we'll see the path, and then the file is located, followed by the pattern line that was matched. And a common combination of options that I like to use with this recursion is searching with the -i to search case insensitive, search recursive, and then the asterisk to search through all the files regardless of file name. And we can see it found the password with the uppercase P. So now let's talk about searching not just one pattern, but multiple patterns at a time, which will look as follows. So we'll use grep -uppercase E, and then we'll provide the patterns surrounded by single quotes and then separated by this pipe, which is also an OR sign, OR. And what it does is it'll search for this pattern, or this pattern, or this pattern. And you provide as many patterns as you'll like, just keep separating them with pipes. You could also use the command egrep, which is the same as grep -uppercase E. The patterns you provide are the same as you would with grep -uppercase E. And with egrep you can use the same options as grep, so you could do a -r for recursion, -i for case insensitive, and so forth. So before we were searching for the pattern user and the pattern password, so this time let's search for both of those at the same time in one command. So we'll do grep -uppercase E, single quote, user, pipe, password, single quote, followed by the file name. And it finds the two matches of user and then another of password. And to show you egrep, it looks very similar. You use the command egrep, single quote, user, pipe, password, single quote, and the file name. And it finds the same two matches. And back to that varlog directory, looking at that file messages, before we search the pattern fail, and then the pattern error. So to combine that into one command, it'll look as follows with grep -uppercase E, and we'll see that it finds matches for both error and fail. Now I want to go over the -lowercase n option, which prints the line number that the match was found in. So in this scenario, I'm looking at a PHP script that provides reverse shells. You don't really need to know what the script does, just know that I'm searching for the variable IP inside of this file. You provide the -n, and in this case, since I'm looking for a variable, it begins with the $sign. Now the $sign is a special character, so if I were to perform a search just like this, it won't be successful. So if I press enter, you see it just hangs. That's because this $sign is a special character, which kind of confuses this grep command. So that's where the backslash comes in, and what the backslash does is it escapes special characters. So it doesn't see it as a special character, it just sees it as a plain text. Now it's ready to execute. I can see the line numbers and I see the $IP matches. And this is also good whenever you're trying to present objective evidence, say to the dev team that has the script that they created and it's causing failures. You could say, hey, this variable is causing issues. Here's all the line numbers that match that variable inside the script. Now to introduce piping into the grep command, instead of grepping a pattern from a file, we can also grep the output of previous commands, which would look pretty similar to this. So you could do a command, pipe that into grep, just give it the option and the pattern. You could do several commands being piped into grep, and then you could even do command pipe into grep and then pipe that into another command. So say we want to look at the processes on this computer, but we just want to see any processes that are related to Apache. So to see processes, we'll use the ps-eaf command. You don't have to know too much about that command, just know that it's a command to check processes on your computer. Over time, I'm sure I'll make a video about the ps command. So it's the ps command, and then you pipe that into grep, and we're looking for the pattern Apache. We can see several results. This last one is actually the grep command that I'm performing myself. As you can see, the command is grep Apache. So if I want to make this a little more accurate on Apache processes, let's try to remove this grep Apache command. So to remove patterns from results, we use the -v and then provide the pattern that we want to remove. So let's recall that previous command and then pipe that into grep, and we're going to remove the pattern of grep. And now you can see we have a more accurate list on processes that match the text Apache. And something you might want to do with this whenever you're looking at processes and you're grepping around is find the PID or process IDs. So I'll pipe the previous command into the command awk. And again, you don't have to know too much about awk, just know that it can be used to grab certain columns of text. It's a whole language on its own, so you could definitely deep dive into this command. But I'll use a simple use case of it, of just grabbing the second column, which is the PIDs of the processes. So it's just awk, print, and then I'm grabbing the second column. If you would want to grab another column, just change this to a different number. Or if you want to print multiple columns, just add a comma, a $, and the column number afterwards. And now we have an accurate list of PIDs of processes that are related to Apache. Now to step more into the realm of intermediate or advanced topics is using regex with grep. Now regex is a whole set of videos on its own, but for now just know that it's a really fancy and useful way to search for patterns, and it allows you to be more specific on the pattern matching. So right here I have a little cheat sheet of regex characters that you can use with grep, and regex is seen in multiple languages as well, such as Python and PowerShell. The idea is the same, but the characters would be different. So not all characters that you can use in Python, you can use in grep. So if you're Googling regex characters, just make sure that it's grep related. So we'll go into examples, but first let's just zoom through this little cheat sheet I have. So if you want to search for patterns at the beginning of the line, then you add this character. This or pipe character we've used before with a -E or egrep, and it just matches or, so pattern 1 or pattern 2. This plus and asterisk are pretty similar, except the plus finds matches of 1 or more times, and the asterisk performs matches of 0 or more times. This $sign finds the end of the string, so it's opposite of the caret that finds matches at the start of the string. The period or dot matches any character. These brackets would match a range of characters. So with these brackets you could do something like these, where this would search any digit 0 through 9, this would search any letter A through Z, this would search any letter X through Z. These curly braces allows you to be specific with the number of occurrences that you want to match. So in this first case, it will find 8 repeats. In this case, it'll find 3 or 6. It won't do 3 through 6, so that's an important thing to know. The parentheses is just to group characters. You use that to group on conditions that you would want to perform in priority. And the backslash, like we used earlier whenever we're searching for that special character that had $IP, this escapes special characters. Say we want to look at the processes that only are being ran by a certain user. So if we were to perform just a basic PS command, it will display a list of processes, and this first column is the owner of the process. So if we want to look for processes that are being ran by a certain user, we would like to look at this first column, which is the start of the line. So let's look for processes that are being ran by this root user. What I'll do is I'll pipe that command into grep, and then as I mentioned, that first column is the users that are running the process. So I'll use the character followed by the pattern of root. And as you can see, it matches the beginning of the line, which in this case shows processes that are being ran by the root user. And if I want to play around with that a little bit, say I want to get the processes that are ran by the root user, but that are also Py scripts. So I'm going to pipe it into the grep command, and I'm going to search for the pattern py, because py is the extension for Python scripts. Also, you might see the text Python in the process. And it returns one result, which is a Python script, and it has the text Python. And from there, I'd look at the script, see if it's vulnerable in any way, such as being writable by anybody. And how that can get exploited or abused is that a low-level user can see that it's writable by anybody and then modify it to be malicious, such as providing them a reverse shell. And since this root user is used to running this script, they're not always going to look at the script before they run it. They're just so used to it, they'll just run it. Unknown to them, it got modified, and now the malicious user is able to abuse it. So to kind of show you what I was talking about as far as a file having write permissions to anybody, if I use the ls-l command, it'll list the files in the current directory along with the permissions that are set for each file. And without going too in depth, this first column is the permissions of the file. And you can think of it as broken down into 4 sections. This first slot will indicate if it's a file, which will show as a dash if it's a directory with the lowercase d, or if it's a link with the lowercase l. And then this section is broken down into 3 repeated sections, where the first 3 slots will indicate the permission for the user of the file of a combination of read, write, or execute permissions. The second section relates to the group of the file and will show its read, write, and execute permissions. These files may be a little confusing as far as what the user and the group is, because root is part of the root group. But if it was, say, the user VillaRoot and I was in the dev group, then it would be VillaRoot in this column and dev in this column. And lastly, this third column shows the permissions to any user, regardless of group or ownership of the file. So this is the section that I'm looking at, and more specifically, I'm looking at this write permission in this 9th slot. So this is a good use case for grep and using regex with grep to try to find files that have write in this 9th slot. So to kind of go over what we want to do, so we want to grab this first column of ls-l. So we'll use the character like we use with the PS processes. And then we want to look at the first 9 slots. We don't care what the 10th slot is because it can be whatever, as long as we know that this 9th slot is a W. So the command we'll use is this one right here. We'll do the grep, and then we'll perform a regex search wrapped around single quotes. We'll use that character that I mentioned to search the beginning of the line, which is this column right here that shows the permissions. Now we'll look at what we want to find in each of these slots. So we don't really care what's in these first 8 slots like I mentioned. They could be a dash or they could be a letter. And just to simplify, we'll say any letter. So we'll put that in these brackets right here, and we'll search for either a dash or any letter, which would be A through Z. And then we'll perform that 8 times. So this curly braces with an 8 is pretty much just performing this shortened. So it does that previous match just 8 times. And then we want to follow with the character that we actually want to match, which is W in this case. And these backslashes are just to escape these curly brace characters. So we'll recall that ls-l command except pipe it into that grep regex pattern match. And we'll see we find that test.py file with the permissions that show write in that 9th slot, allowing any user to write to the file. Finally, to get into the last example, which is also regex, we'll search for phone numbers. And the tricky thing about phone numbers is that it can be in different formats. So it could be with the first 3 digits surrounded by parentheses, or it could be no parentheses, but the digits are separated by dashes, or separated with spaces. It'll create this confusing looking grep command, but if you break it down, it's not as complicated as it looks. Mainly, it's all of these backslashes that makes it look a little bit scary. But to break this down, we can see that through all of these 3 different possibilities, it's kind of similar in that there's a group of 3, followed by a group of 3, followed by a group of 4. The only difference is sometimes between those, it's either separated with a dash, a space, and in this first case, surrounded by parentheses on the first 3 digits. So, to cover this first section, we'll look for parentheses, any digit from 0 through 9, and then repeat that 3 times, which will cover this first scenario. So, if it doesn't have that, let's do an OR command, where we say, yeah, it can have parentheses, or it can just be a digit, 0 through 9, and then repeat it 3 times, which is like these second and third examples. And then after those 3 digits, it could pretty much be whatever. It could be a space, or it could be a dash, or any character. And since these 2 sections are pretty similar, let's repeat that first condition 2 times. And so that covers up these first 2 sections. Now this last section of 4 digits is pretty simple. Just search any number, 0 through 9, and then match it 4 times. So we'll type out that super long and scary looking regex, and then I'll end it with an asterisk to just search through all the files in the current directory regardless of file name. It finds 3 results in 3 different files, and you can see the 3 different formats. And that pretty much covers the whole video. Again, feel free to check out my blog at VillaRoot.com, and also follow me on Twitter at VillaRoot. And don't forget to like and subscribe. Also place in the comments what sort of videos you would like to see from me. I'll also be posting videos related to PowerShell, this bash. I might throw in some Python, and of course I'll throw some hacking videos. So thanks for watching.